15627, Chapter 4, Specific Maintenance Operations, Section 1, Maintenance Track, 4.1, Lining of the track. The alignment at the same time the surface is the line rail. The line rail is always a line surface fitter first and second, then the second rail. The line rail is the north and east rail, north or east rail. Horizontal alignment existence is not conforming to the grade of the curvature standards may be maintained and is provided by the record described in each deviation. Standard necessary operation restrictions are imposed. Restrictions shall be tailored to each specific situation that may be included, such as items of maximum speed, use of push bars, maximum car engine combinations to assist the cars of cranes in tracking to reduce the wear of the share or substandard curves, and suggested that the tracks be oiled. Track oilers may be installed on government-owned locomotives operating on over sharp curves. 4.1.1.1 Railroad trackage. All curves should have designated degree of curvature. Curves of radii less than 300 feet of the frogs. Number 4. Bellows should be approved of higher authority than the installation. The radius established of the activity is the baseline design theoretical radius. The radius is the best fit of the overall existence condition. Curvature alignment that deviates established uniform and more than amount of Appendix B is considered defective. The spirals as designed or as developed as shall have been smooth transition. The ground level crane horizontal rail alignment is curved crane track shall be designed as laid out based on an analyzation portal crane flow requirements of traveling curved rail or curved track. This analysis is required of the float and compared to the float compatibilities of all cranes to clearly define the problem area. The problem may resist in limited restriction of the crane operation, reduction to running gear on the crane, realigning the trackage. It should not be noted that available design float of the crane may not necessarily be operational. Curved crane trackage cannot be checked on or line and string line method described herein. 4.1.41.2 On the tangent, the railroad brought the correct on the tangent track. The rail line of the rail is brought correct to the line of the eye by the use of its transit. The other rail is brought to the line, correcting the proper gauge of figure 4.2 illustrates the lining tracking operation. 4.1.8 Curves. The line trackage of the curve is more complicated because of the curve must not only be uniform throughout the length, it must case as an easement of the spiral into the curve, which must be provided from both tangents. 4.1.3 The curved lining of the track on the curve is more complicated because the curve must not only be used in uniform of its length, but in its case, an easement of the spiral into the curve must be provided by both tangents. 4.1.3.1 Compound and reverse curves shall be provided in easements of the spirals from one curve into the other. 4.3.2 A transit is employed as area stacked into the line of the new work and making of the major changes of existing track layout. A transit should be used in laying out the new work and marking the changes in existing track layout. The string line method can be used and is not recommended for the work of major changes. The string line is the best used for the determining of the degree of the curvature and locating and correcting irregularities in the alignment of the curvature. Field operations method and calculation error is given as the area manual as Appendix F. 4.2 Surface track general. All tracks shall be laid, maintain and correct surface evaluation. Surface out of surface refers to the raising of the track structures to a new grade. Spot surfacing or raising layout spots of the original uniform surface. Correct surface implies that the plane across the top of the rails at the right angles up to the rails and the level of the tangent has the correct inclination of the curves. The super elevation, paragraph D2, appendix D, and is used. The track level is used in all surface working for 4.2.1.1. Pay special attention to the surface line and track at the engine approaches to the bridges and trestles of culvert turnouts and crossings at the platforms. Then you see a handsome guy eyeballing the track. Here's the rail forks as they're lining the track. 4.2.2 Working against the current traffic when raising the track, except for the heavy grades where it is desirable to work upgrade. 4.2.1.3 Before raising during the hot weather, be sure the rails will not warp and buckle. Considering the amount of rail openings and joint tightness of the bolts Position of the rail anchors almost of the ballast into the cribs and end of the ties within their danger and the buckling loosen track joints in both directions from the danger point to allow expansion. 4.2.14 in bonded territory. See the ballast that clears the rail of the prevent leakage of the current. Separate the ballast and base of the rail by space of about 2 inches. 4.2 the grade profile grades shall not exceed the design grade except for as noted below. Railroad trackage gauge may be spot checked in random intervals as hand level and rule, and all grades shall be connected within a vertical curve. Switches must be installed on the grade. However, no part of the switch shall extend into the vertical grade curve. Ground level crane trackage on existing trackage, which is graded excess of 1%, is if cranes do not encounter acceleration and deceleration problems in transverse tracks. No action required. However, if problems appear, if other deficiencies dictate complete replacement of the track, the criteria of 1% per maximum grade shall be followed. Curve switches and frogs shall be on the only level grade in order to minimize the possibility of derailment. Note if the existence of not level or if there is a difference in elevation of 1 inch between the inside rail and the outside rail, the crane flow shall be analyzed to determine whether the wheels will clear and permit the truck assembly to swivel and cause derailment. Observing the position of the wheel flanges in relation to the top of the rail and reveal the areas of them become critical. If the wheel be taken during, if the wheel flanges be clear of the top of the rail, extreme caution must be taken during operation. Immediately action initiated to close the deficiency area of the question should be classified as critical as well marked as so the crane operator should cognizant of the deficiency. The 4.2.3 elevated crane trackage railway should be kept in the near level grade. The rail gradient must be kept all below the slope and will always cause the crane to roll freely. Present problems starting the stopping in the crane. Here they're surfing ascent with a level beam. 4.3 cross section evaluation. The difference between the rails shall be the limit shown in Appendix B. Railway trackage on curvature trackage design super evaluation outside the rail shall no longer the inside of them, and the maximum cross-section elevation differences should be within the limits of Appendix B during the design of super elevation based on the degree of curvature and speed on curved trackage of the industrial areas transferred at low speeds. The super elevation is not required. Ground level crane trackage when the difference of elevation of the inside the rail and outside rail exceeds 1 inch of the crane float. Analyze appropriate action taken. 1.4.3.3 evaluate crane trackage. The cross section differences. The evaluation shall not exceed over the limits established activities of the engineering judgment of each specific traffic system. The tolerances recommended by manufacturer when known. Hand jacking. There are two methods of surfacing the track, and one is used where the less is the 2 inches other than where is the left is more than 2 inches. The two methods are discussed below. 4.2.41 is starting the raise and the lift in less than 2 inches jacking points and shall be placed spaced 8 and 12 feet apart. Place the first jackets apart approximately 10 feet ahead of the starting point of the rail. Place the second jack 10 feet ahead of the first jacket. Raise both jacks to give an even grade at the starting point to the second jack. Tap the ties and proper point is approximately halfway of the jack. Bring other rail to the proper surface of the aid of the traffic level and then move the first jack about 10 feet ahead of the second and raise the rail at this point. Tap it halfway between the jacks. Follow the same procedures to bring the other rail in proper surface using the track level to determine the amount of lift. 4.2.4.42 to lift the track over more than 2 inches, locate both jacks to reduce spacing between the jacks to avoid the permanent bending of the rail. Raise the first jack to the bring in the grade between the 0 and the first and 1. Raise the second jack enough to provide the reasonable runoff to the new grade of the low spot. Tamp ties and point approximately 1/4 distance between 1 and 2. Raise the second jack to bring the rail proper grade. Move the first jack ahead of the proper space and tamp and as before, and caution the same operations full of length of track raise. Caution is the method of jacks must be placed on the head of the rail joints to prevent strain out of the joint bars figure 4.4. 4.2.43, the raising of surface track, the inner rail of the curves, line rails, tangent grade rails, bring them to the surface of the aid of the spot board, and refer to the grade stakes, bringing the second rail to the surface of the aid of the track level. 4.2.4, bring the rails to the grade of the tamp tie, set tie, plates, gauge track, drive spikes fully before jacks are moved ahead. Place the tracks, jacks, and cribs between the ties outside of them. Set them vertically. If the jacks are to be placed between the rail, set them in a trip and position provided in the flag protection. 4.3, tapping. Systematic uniform tapping is very important to the maintained current surface line. See the figures 3.7 and 3.9 in paragraph 3.6.3. 4.3.1, tools, pneumatic, electrical, gasoline, and other mechanically operated hand tappers may be used. And from the tamping, the type of the tools, somewhat from the different materials as follows: from the broken stone, crush, wash, gravel, slag ballast, picking or bar, ballast, and power tap. Power equipment will be fitted in the tool having and similar to the tamping pickup face vibrator tool. 4.43.1.2, the gravel chats, inserts ballast and uses above and ballast fork, ballast spade tapping rod, tapping bar, power tamper. For the heavy traffic, a tamper picking up, tapping bar, and power tamping should be used within the proper tamper. Uses the tamper tooling within the tamper end of the sufficient areas for the light traffic shovel tamping is sufficient. 4.3.1.3, for spotting and tamping picks, ballast forks, and ballast spades, a shovel, and tamping bars and power tampers may be used. Methods: after the track has been raised on the jacks to the true surface of the pack the ballast firmly underneath the ties. Tamp the tie. The tight bearing is obtained between the tie and the raised rail within disturbing surfaces. Following the tampering methods apply. 4.3.2.1, tool positioning. Regardless of the kind of ballast and kind of power tamper used, the two tamper toolings must always be worked out each of the other at the same time. Ties. Start power tampers formally have a vertical position as usually. Use of the direct against the side of the tamper. Work with downward past the bottom corner, after which the tool may be tipped down to the force of the ballast directly under the tie. 4.3.2.2, tamping distance in a tie. Tamping ties to 8 feet. Cross ties should be tamped at 12 inches side of the rail end of the tie. 8 feet by 6 inches cross ties should be tamped and 15 inches inside the rail of the end of the tie. And 9 feet cross ties should be tamped with 18 inches inside the rail of the end of the tie. Here's a picture of them jacking the rail. 4.3.2.3, caution: one tamping of the center of the tie above the stayed tamping line limits of the center area should be filled within the ballast fork, and both sides of the ties must be tamped and simultaneously tamping, and the inside-outside of the rail should not be done at the same time. 4.4.44, gauge measurements. The gauge of the track is less annually, more frequently volume track for local conditions of warrant. And gauge of the railroad trackage is measured between the head of the rails and the right angles of the rail to plane 5/8 of an inch below the top of the railhead. The gauge of the crane trackage is measured in a center-to-center railhead. 4.4.1, railroad trackage. 4.4.1.1, train tangent tracks and curves. Standard gauge of 4 feet 8.5 inches is used in the tangent track on the curves of 8 up to 8 degrees. On the curve over 8 degrees, the gauge is 1/8 of an inch for each increment of 2 degrees of the maximum of 4 feet 9.5 inches. Moving inside of the roll rate of the change is standard to the widening gauge of 1/4 of an inch and 31 feet along the spiral curve of the tangent adjacent with the curve on physical conditions do not permit in normal transit of 1/4 of an inch. 31 feet rail of change is standard and widened gauge for covers and design standards of not trackage inspection criteria. 4.4.1.2, turnouts and crossovers. A turnout or a crossover, a curved track of the parent and parent. Gauge of the parent and track is determined with the degree of the curve as described, and the degree of the turnout is the curve determinant of the algebraic sum of the two curves. A curve of the tangent plus or minus of the curve of the main. Paragraph 331.4, the gauge adjustment is made accordingly. Ground level and crane trackage. The gauge is on the curved trackage shall in no circumstances require more lateral float of the crane provided. 4.4.1.4, evaluated crane trackage. The gauge of the trackage shall be held in a tolerance So that's specified with causing the manufacturer computed from the existing crane wheel spacing. 4.4.2 Limiting factors of corrective maintenance variation of the gauge. The limits show in Appendix B the acceptable provide there are no alignments attachment to the foundation defects. Here's a guy gauging the rail 4/8 of an inch, 4 feet and 1/8 of an inch. The gauging of the track. What causes the training start excessive abnormal rocking and bouncing variations from the gauge of the wide rare translation the series provided in changes of relatively uniform constant of two standard rail lengths fastening secure that the alignment of the prescribed limits of wide gauge caused by the rail corrected in the closing or other by interior interchanging and low high rails. Caution: interchanging and low high rails can be cause failure to do the change of the stretch location. 4.4.3 Procedure re-gauging the standard track is used in the current grade. Gauge is checked and frequently replaced in variation of 1/8 of an inch or more. A spike pulling or driving is done on the rail opposite of the line. The gauge is not removed until all spikes have been driven and spikes are pulled in the standard spikes are pulled with a standard claw bar or spike pullers or with switches and frogs and guardrails. Whether the claw bar will not fit on between the rails, spike puller extension is called. Use the Crozatine tied plugs are not given in spike holes before the respiking. Correct to the gauge should not be made until striking the head of the driven spike toward the rail. Spikes have been removed and relined to the gauge and spikes redriven. 4.5 Spiking will follow the standards of the paragraph 321 SEP H K and 4.6 Rules of turnout installation. See the paragraph 2 and 2 and 331 in general discussion. The figures 2.1 and 2.14 is descriptions, turnouts, and crossovers of appliance in place and maintained in accordance with the standard planes of the following. 4.6.1 locate the point of the frog and the point of the switch. 4.2 relocate any main track joints that come within the limits or switch point or the guardrail. 4.6.3 caught the lead to the bearing of the lead of the turnout lead no longer than the main track lead. 4.6.4 First point put in the head blocks the gauge. The plate is a two-sided plate. All ties and switch points of the frog, their slide plates, brace and heel plates, guard plates, and the plates brace is unbroken in line and rail in line and fully spiked position where they are turned out and side or held in place in temporary. Bend the rail turnout stock rail accordingly to the data of 3.3 paragraph 331.17d. Couple the stock rail main track switch point or heel block in place later if used. Lead the rail and frog and endless of ties and turnouts. During this cutting and drilling is to be necessary to complete the main track from the point of switch to heel of the frog. Here's the pulling spikes with the claw bar and an extension of the turnout. And here is a power operated spike puller. Take out the old mainline track, set out the turnout part following the order, place stock and rail switch point, place the lead rail frog. 3. Make the connections of the frog at the stock rail. 4. The spike frog is exact gauge as the heel bolt or the toe point. Place the joint bars and tightening bolts, complete spiking from the frog and to the heel of the switch point. 4.6.8 Do not permit the trainer movement of the main trackage guard and correctly place and spiked. All switches and turnout have been spiked in correct position and switch position in the spike against the stock rail, and the free end of the stock rail is fastened to prevent the movement. In applying the switch points at turnout side, I see the gauge is correct and 12 inches ahead of the switch point, and to the slide and die where the switch point appears to tamper. 4.6.10 Adjust the stock rail so that it does not bind against any switch point and cause them to open. To test this and operate the switch point, see that the point touches the stock rail first. Spike these slide plates, install the remaining slide plates, and brace the working each way of the center. 4.6.11 Putting on the slide plates of the bar, not a pick. Do not attempt to draw the gauge within a spike draw the gauge with a spike. Put the remaining switch ties line and surfaces main track. Couple the switch point and turnout lead of the set lead rails. Spike turnout, lead the proper line of the turnout curve. Complete the workout and setting on the remaining guardrail and switch point. Guardrail is fed or switch point is installed. Setting and adjusting and switch point operating mechanism. Checking the line. Engaging, spiking, and surfacing. 4.7. Generally heavy of traffic wintering month is generally indicated in a poor drainage or ballast conditions, which is most likely corrected as the frost leaves the ground until that is caused and eliminated, having a corrected temporary using shims to raise the rails either earlier than the higher spots, provided an easy grade the length of the temporary raise. Here you see the application of the wooden shim to the rail braces. The shim we go back to the length of temporary raises is called the runoff. Note the criteria: the maximum runoff is contained by the Appendix B. 4.7.2. Shimming is necessary, will be done, and provided by easily and safe runoff gradients. When one side of the truck is more than the other, the proper cross level may be restored by the shims installed. Care must be taken out of the curves and maintain the proper curve of elevation. Heave and ties will not be added or otherwise cut it in the lower height of the shimming under the tie. Prohibited except as an emergency in which they shall be removed in condition otherwise and taken care of as soon as possible. Rules of shimming and bracing when installing shims. Track level and brake gauging will be used to ensure the proper gauge and surface. 4.7.3.1. The shimming before the shim is placed high, all spikes, poles, and ties must be plugged and treated in wooden ties and shall be free of ice and snow and other obstructions. The areas of shim, the full bearing of the shim and the tie shall be provided. 4.7.3.22. Shims of the same length will not be used together on one rail and the tie. One 12-inch shim must be used on the top of 24 inches top to 3 foot of the 6 inches shim. One 24-inch shim may be used on the top of 3 foot 6 inch shim, and one 24-inch shim may be used in one top of the 24-inch shim has been placed on the top of a 3 foot 6 inch shim. The possible use of only one shim with or 2 shims are required, or the lower shim must be maximum thickness. The 3 shims are required to lower the shim. Each shall be made maximum thickness. 4.7.3.3. The tie plates are special shallow bases patterns shall be ribs on there be as enclosed and installed to the shims. When the tie plates ribs the bases in the use, they should be installed on the top of the shims, and shims shall never be installed on the top of the tie plates. 4.7.3.4. All cases of 12-inch to 24-inch shims are on the 12-inch to the top of the block and 24 inches on the shim is installed on all spikes used in long enough to provide a minimum penetration of 4 inches on the tie, and in case of properly and immediately spiked to the tie of the 7.5-inch shimming spikes. In case of all 12-inch and 24 inches installed on top of the 3 foot by 16 or 3 foot by 6 inch trim, all spikes through shorter shim shall be long enough to go through the 3 foot 6 inch shim and have a minimum penetration of 1 inch of the tie. 4.74 precautions. 4.74.1 driving shims. The angle between the spikes weaken. The track is prohibited in shims and shall be squarely on the top of the tie, and spiked is driven through the holes provided. 4.7.42 Wood. Other types of rail brace should be not used within the shimming is done on tangent on the curve equipped and will shoulder the tie plates and the type of to be used on the shim, whereas the shimming is done and curved and not yet equipped on whether the tie is equipped to shoulder the tie plates and type of to be used in shims with otherwise approval of the rail brace installed on the shims. 4.7.5 Reestablishing normal shim as the frost leaves of the ground heaved and placed and returned in their proper level. Shimming and reduce in front time in order to maintain the front surface whether the ground. All shims may be removed dearly from without delay from the track. Any imperfect surface corrected removed shims and shimming spikes should carefully be preserved from the future use. 4.2 Maintenance of track, street crossing, and paved areas. Proper attention must be given to correct deficiency and occur the crossing to the around track of the paved areas. The maintenance of the track bed trackage will same outlined into the foregoing chapters of section, except for the inspection will be difficult. The additional maintenance may be required. Paving, planking, and to ensure the smooth operation of vehicles in the area because of the track maintenance is paving and the move costly and the consuming material supporting and containing the track structures and must have all low maintenance potential as possible for the reasons material deterioration or changes the gradient is caused. Gauge recommendation. Drainage is critical and is present to more problems crossing the other points of the roadbed, catching basin, gutters, ditches, and pipe draw. Drains and culverts as appropriate must be provided in intercepting divert service and subsurfaces as depressed and downhill crossing base materials, underlying trackage, pavement, and appropriate well graded and granular materials, prevent pavement and service, and adequately crown of slope and directed water in order to catch basin and additional information of the drainage is included in section 3 of this chapter. 4.10, the ballast is under properly maintained pavement crossing normally requires maintenance. However, the balance is not illustrated installed properly on all good foundation and beginning in the surface over the ballast permits the infiltration of water and silt and other debris, and as the ballast is fouled and interfere with the drainage and the track that the crossing and ballast and other the ballast is fouled, and the ballast and sub-ballast should be removed and not less than 2 feet of the bottom of the ties, less than 2 feet beyond the ends of the ties into the first joint of the rail. The first rail join away, the crossing replaces according to the critical of Chapter 3, Section 2, 4.1. The condition of the cross ties under the crossing ties of the pavement cannot be determined without removing the cross materials, pavings, and untreated ties were originally installed. There may be seriously damaged insect attack decay of the short periods of time. Figure 4.9 and the first indication of familiar may be setting of the rails, paving, and the change in the trackage gauge, and whether the track is torn up and replaced with the ties, not only to interfere with train operation, but also as the area crossing the vehicle plane traffic. The traffic is undercovered in the repairs, and the traffic crossing the pavement should be brought into the proper condition. Drainage and ballast should be investigated, replaced, restored, and the new ties. Also, the ties should be replaced at the same time. Normally, 9 feet treated wood ties in other ways is the lost limits for crossing. However, the concrete ties should be considered when their replacement needed because they require no maintenance and hold on to the trackage gauge. 4.12, a general rule: bolted rail joints are not allowed within the crossings widths and rail lengths, such as the joints, and not included that they should be properly welded. Nearest bolted joints should be set at a minimum of 6 feet outside of the crossing. The precaution must be taken to ensure the adequate adequate continuing lap bond of the rail with crossing. All rail and metal fittings within the crossing shall be given the coating approved. The rust inhibitor rails should be gauged and lined accurately and double spiked when to the ties. This ballast under the track shall be solidly tapped and to bring the track to the guide. If the concrete ties are to be used, the rails will be firmly bolted to the ties and track to the brought to the grade. And here's a picture of a decayed underpaved road. 4.13, the crossing. 4.13, the crossing surfaces and materials. General crossing surfaces must be as smooth as possible. The materials selected and the purpose of suitable type of traffic using the crossing. Although desired to match the material texture of the appropriate pavement, consideration must be given to the material and installation economical. Maintain that they will not have a long life and materials such as importable cement, concrete, bituminous concrete, or economical install there correctly. To remove the replacement wood plank and prefabricated maybe and be a little more costly to install. They're removable, reusable, therefore they are most economical to use in the long run. Further, though, they are easily removed and replaced from facilities of the inspection of the traffic plank type crossing flangeway other than the open doors and the ties which expose the subgrade ballast of the water, silt, and debris of flowing to the open. Regardless of the material, the flangeway provided 2.5 inches for the tangent nominal curve track. On the curves over the 8 degrees, flangeways were widened to 2 3/4 of an inch. Rubber and plastic crossing pads, rubber and flangeway fillers, and available. Sometimes types of crossing should be installed, especially in areas where small wheeled vehicles is using a crossing. 4.13.2, street highway crossing. Street highway crossing should be at least 4 feet wider than the crossing and the width of the approach pavement, and the crossing has to be repaired, replaced, and crossing the same within the approachment pavement. The cross width shall be at least 2 feet of each side. The additional width is necessary to reduce the hazardous vehicles running and off the sides of crossing. Figure 4.10, the most frequently used crossings materials are listed below. 4.13.2.1, bituminous concrete within where traffic is light, and entire crossing of the constructed bituminous concrete. The very little traffic are the flangeways may be formed and running the locomotive wheels through the mixture of the place and rolled, and some finishing may be required of the material having been shoved out of the flangeway. However, the crossing within the highway volume of the traffic, heavy truck traffic, and a flangeway guarded is needed and protected the edges of the asphalt section and between the rails. The guard may be constructed of wood, metal flangeway guards, and fabricated used rail. Figure 413 purchased in commercial sources. 414, 413 Portland cement concrete construction crossing and cast placing concrete requires closing. Double track crossing. Here they show the bituminous concrete crossing in the flangeway within the engine wheels. Otherwise, here is the plan for a crossing rail. They have fill in the counter bore, the mastic material, and lag screws, washers, roadway pavement, bevel timber shown, 3x8 by 10 foot boat spikes, timber, top of the rail, roadway pavement, the plan, flexible pavement, a bore, a top pavement, timber even through within the T-rail, counter and bore of the 1 3/4 deep, 6 inches on a tie, nailed 2.5 inch of roadway pavement. There's roadway pavement. Separated front field side of each rail and keep the tops of 1.25 inches of the top rail asphalt saturated felt and 30-pound type. All through this crossing type shall be sawed from a size 4 and spacing shall not be exceeded for 20 inches. Use of the flangeway rails, metal flangeway guard. Crossing limiting vehicle traffic in one lane during the construction of concrete curing. The type of the crossing, however, provides a smooth riding, durable surfaces, poured concrete crossing, and costly to remove and replace. 413 2.3 cross concrete planks. The type of material provides a long-lasting surface of all units of traffic. Service of the type of Portland cement concrete plank available in the market for this purpose. Special care must be taken to ensure that even the length of each plank. For figure 416 that gives a plan section of views of typical installation. 417 a typical installation, sometimes cast concrete crossing, and are available within the rubber fillers and flangeway. Figure 4.18 wooden plank cross tie that has been successfully used for the many years. Trusted timber that will last a long time may be required to retighten the lag screws from time to time as they become loose, and timber of the flexion under the traffic. Well-maintained wood plank crossing is shown in figure 419. 413 prefabricated rubber planks provided in smooth riding, durable maintenance, and free corrosion crossing. Typical installation is shown in figure 420. Typical crossing, as well as other prefabricated types, is salvageable and can be reused. And modern plank crossing, modular crossing is durable, smooth riding, practicable, maintenance free. This section is molded and if a section is damaged and replaced without disturbing any of the section. Figure 421 used as rail crossing and slippery and wet do not afford a smooth ride in small wheeled vehicles. 413.2.7 used crossing the occasional fabricated rail has been worn and further than the track system of 422. These rails should be had in the same way of running the rails laid side and side, head up between and parallel running rails of adequate flangeway used in railing side slippery wet do not afford a smooth ride of small wheeled vehicles. 2-component epoxy rubber and a port and 2-component epoxy combined with rubber and is available. Seals of ballast from the intrusion of water. The type crossing is expensive. 4.14 the track paved. The type vehicular traffic particulars, the size of wheels and the tire determines the type of material construction used adjacent to the between the rails and industrial areas. Normal casting periods of Portland cement concrete is asphaltic concrete pavements used as flangeway guardways appropriate the vehicular traffic. In figure 4.23 small wheeled solid tires are used as a rubber flangeway as recommended. Flangeways all must be formed and used as girder rails. A rail in figure 423 through the crossing pavement or by the piping placing and using the rail and head against the web of the running rail. Cost and place of concrete crossing. And then they show precast of concrete slab crossing. A precast of the plank crossing and a precast of concrete rubber flangeways. Timber crossing. Here's a rubber plank crossing. A modular plaque crossing. Used rail asphalt filler. Girder rails, trackage in paved areas. 415. Signs and signals. Crossing signs and signal maintenance must be given them a high priority to assure legibility and visibility. 415. Highway crossing signs and signal standard and highway railway grade crossing shown as figure 424. Grading crossing signal in 425. Location sign signals in 426 for the details appropriate crossing signals and see manual uniform traffic control devices, bulletin number 6 with the Association of American Railroads. Road high grade crossing protection, chapter 9 area manual. 415 maintenance signal circuits electrical mechanical signal inspection maintenance should be conform to the area requirements as the manufacturer recommendation. Circuit continuing checks battery from the level operation trickler charge operating test to relay point of the checks light bulbs tests and related and checks inspection must be made periodically specified required by the installation and maintenance of the serving railroad and indicated defected must be corrected. In 4.15, a single cable must be buried around the main trackage switches and signal locations or cables are buried into the top ballast of instrument housing switches, signals, and tracks and circuit systems and territory interlocking plants and switches equipped with electrical locks as well as automatic blocks. Signal locations, maintenance, and employed working on the roadbed at these locations should be informed by the single force of exact locations of these cables. Machine operators must be exercise the care to avoid damage to the underground cable of these location. In case of the location of the cable, do not work in the digging machine within the interlocking home signal limits. Here's a typical railway crossing sign. Railroad mounting brackets. I can't read that. Here's railroad crossing signal, a drawing of a typical variation mounting of permission of details shown on the signal drawing 1615-3. It's about 7 feet high, and this shows the blind spots of a perpendicular railroad location of warning signs and signals. Section 3, the maintenance of a roadbed. 416, the general good drainage is most important for the single factor of the roadbed to provide maximum support of the track structure. Subgraded should be kept as stable as possible for the poor damage not only affects the roadbed underlying each of the structure, but as also side cuts or other track sides. The drainage deficiency occurs without correcting and by the normal maintenance practice. Engineering assistance will be requested. Open ditches and pipe draining shall be maintained. Open ditches and drainage shall be maintained to the function of maximum capability. Weed control center, efficient methods of control, and snow and removal. Important factors of conjunction, water runoff, inadequate original drain system shall be corrected as soon as they become evident. 417, inspection, repair, all methodically timely inspection of the prompt correction of large, small defects of necessary for economical maintenance of the drainage system. The object is to preserve an original trackage roadbed section of preventing obstruction that to divert the impeded flow in the drainage system. The emergency repairs of the drainage system must be made when conditions require such action. In general, repairing, cleaning, and should be conducted annually, preferable spring and after periods of unusual storm and rainy weather. 418, subsurface drains, water falling in the ballast soon soaks whether they through the two in the subgrade impervious subgrade and not properly graded. As soon as the water must be drained off ditches, causes pools and form within the soft subgraded, results in low spot. Some are possible heaving in the winter, and poorly drained subgrades are reflected in the poor traffic resurfacing, raising traffic instead of providing proper subgrading, and only temperature measures and slopes of the drainage may vary from 1 inch to 2 feet and 1 inch into 5 feet. The only remedy to eliminate the wet spots is to reshape and subgrade of the water. It will flow toward the ditches. Always stabilization can be optimized with concrete subsurface and grounding, and the trouble is localized in very small areas. Subdrained may be used to drain off the excess water. This is a picture of ditches with silt and vegetation. 419, the cement grouting and soft road bed. 419, surfaces and drainage. All surfaces must be sloped and toward the drainage and system. Slopes maintain minimize erosion during runoff drainage. Ditches structures shall be kept in condition of disposal. Runoff quickly obstruction that causes water to remain off the pools shall be removed. Erosion on other sides bottoms of the controlled and lining of the native grasses or by the checks of dams and rip and wrap or pavement. 419.1 Ditches maintenance constant problems and faulty design construction. Permanent corrective measures and measure may be required. For example, if the gradient is unsuitable and ditches may occur to the steep, may be accountable. Silt and too flat, uncheckable growth in vegetation obstructs water flow, raises water level in the ditches. The water penetrates at softened bed of the restricted drainage off the roadbed. Some soils were always and the slopes are eroded from rainfall, undermined by the flow of the water in the ditches unless the gradient is correct and stream bedded clear. Erosion of the ditches and the side slopes is increasing the silt of the ditches figures, and therefore their slopes must be stabilized and flattened, and reduce maintenance of the repair measure and must be determined and fix existing conditions. 4.9.1 the causes drainage failure. Causes the failure to maintain mentioned generally in procedure paragraphs following describes the causes in more detail. Erosion occurs with velocity of water and wind of the sloping and banking. The ditches cause the dislodging slow of the areas carrying out the degrees to which in the velocity of the ditch and the slopage upon stability and soil protection have been given an additional stabilization. Loose and sandy silt and soils early and eroded almost any velocity, such as the soils vegetated cover often rip-wrap concrete blankets. Concrete blankets have been extended sufficiently in the ditch top and ditch bottom to prevent the undermining of the most satisfactory solution of the erosion, controlling of the flat slope and reduce the velocity of the water, the rate which erosion minimum of the yet prevalent unacceptable siting. This may require construction and installation, check dams and flattening slopes and beyond the scope of maintenance. 419.2.2 lack drainage. The drainage is inadequate, unwanted, and water remains in the rain road bed long enough to soften the gray. Dirty ballast can be reduced into drainage water effectively as the stop drain and properly shaped and subgrade and pocket. Erosion of the side slips. The pockets have then developed in subgrades and impounded the water detriment of the track system. Subdrains have been clogged, built up in the silt and adjacent ditches to reduce the flow of water from beneath the track structure. Beside the weakening of the subgrade, trap water during the winter can cause heavy heaving in the water, freezes and further retards the drainage from increasing the problem. Which increases the problem. 419.13 the corrective measure whether it be used in an effective off-track power equipment gives more than an economical result of two cleaning interception drainages, ditches, and methods of hand working may be unnecessary to equipment and not available where conditions prevent access of mechanical equipment. Ditching the ordinary material of the side ditches and cuts and must be subdivided in two principal classes and shows cuts and deep cuts. So shallow cuts, ditching the shallow cuts, and may be done by road graders as the equipped blades is shaping the ditches and slopes of the drag lines under some conditions of track drawn scrapers. Some ditches shall not be down by the hand, whether the magnitude must be justified as heavy equipment. 419.3.2 deep cuts of valuable material may be removed and comparatively small to the work usually performed by the graders, and the handwork will be resorted to the unless careful analysis of those use of power equipment is not possible. 419.3.3 the use of road machinery when the volume of the material is removed or the loaded larger the cuts are long enough to the point that the disposal of the remote of the use of the powerful ditches other than the heavy excavating machinery is justified whether it is unavailable. For example, if the terrain is such as drag lines can be working along the top of the cut of comparative deep cuts and be cleaned quickly and less expensive other than the methods with no interruption in railroad transportation, power scrapers and trucks, power shovels, and maybe their most particular machinery to use 419.13.4 use of a car-mounted machinery where the depth of the cut desired to the excavated material of their other conditions, power operated ditchers and drag lines mounted on the cars effectively for the work train is necessary for usual arrangement and place of the ditcher drag line, which is two air dumped cars before using the work of trains or on the track equipment. Very careful analysis should be made before the situation whether the cleaning can be done as satisfactory methods of affecting the movement and the personal equipment capabilities of organization or are not adequate to perform extensive maintenance, repair, rehabilitation of the railroad track. Consideration shall be given to the use of contractual services. Secondly, in Figure 430, you see an inadequate drain road bed. 419, disposing of the surplus earth material in the case of all waste of material disposed and so that it will not wash back into the cut. Material removed in the side dishes shall never be cast into the adjacent slope. Waste and the disposal along the embanking it should be disposited in evaluation between the bottom of the ballast. 420, the storm pipe drains of regular program of maintenance of the pipe drain shall be conducted and built. Coordinate plans must be kept current regarding the change of the system. Limits of the curved drain shall be marked to the adequate signs that facilitate inspection maintenance. Routine maintenance outlet ditches leading from the out pipes shall be kept when adequate with the ensure the drainage slide banks and maintain sufficient slide that the material shall be involved and will not slide down ditches and should maintain the free vegetation of debris other than obstruction, irregularity, and alignment other than the grade other than tendency to causing a silting and scoring and should be avoided. Outlets pipe screen as an outlet shall be kept in place of preventing the small animals from entering the plot pipes. When sighting occurs of the outlet, screens shall be removed from the opening and cleaned. Special care shall be given to the outlets and may be certain in the stoppage does not occur. Overflow occasionally drainage pipes and discharging near bridges, culverts, and subject to the overflow of the backwater during the high water. Inspection shall be made by as soon as water reduces it is if necessary for the pipe drainage system to flush. 420.1.2.2 the frequent inspection of the maintains shall be made of the risers and tendencies of the soap must be carefully washed, and when it occurs in a marked degree, the entire system of the remains of flush water within the water car, other than convenient supply, special and necessarily for the system involving near level grades. 420.1.3.12.3 vegetation, trees, bushes, and vegetation within the deep roads not allowed to grow near any line surfaces, drain line. The roots seeking the water may fill the pipes, causing the stoppage. The system correction failures. Rapid seeding of the main drainage indicates the obstruction of the A-level spot. Reverse grade of much must be located and corrected. In the excavating obstructions cares of exercise prevented following drains and excavating should be backfilled in permeable material similar to that specified in original design and tendency toward the further development of water pockets and soft spots. Heavy must be studied and the test holes dug. Determining the direct causes of failure. The failure cause and defect pipe occur immediately. Repairs and shall be made in heaving and cause obstinately water pockets. Soft pockets are not be tapped and literal should be installed. 421 soft spots and water pockets. 421.1 general soft pockets, water pockets exist localities of social conditions unfavorable, satisfactory maintenance, particularly in clay. They will be found in both cuts and most generally in clay cuts. In soft spots in both ballast generally has been settled in the roadbed. Formerly throw the pockets under the track. It is a condition usually causes the sub-ballast roadbed to be pushed out laterally, oftentimes raised in C figure 431 and 432, thus forming the prevented water drainage of the track. Condition and variable results of the water pockets, usually the methods of surfacing, tamping, spotting water pockets. Soft spots, water pockets, and shall be propped in attention because they soon develop in serious defects. The longer they exist, the more hazardous they become, the greater the resulting maintenance expenses of the time and cost involved in providing the permanent remedy. The corrective measures in minors and soft water pockets, the maintenance crew may be corrective action, increasing drain fields. However, in addition addition to the pipe drains view new and have developed in roadbed grouting and the driving of the poles or ties, the use of sand piles and air surface. The situation should be studied by the engineers to see whether the method of probably giving the most economical satisfactory method. 421.2.4 421.2.1, main drain methods. Chest holes should be measured in intervals frequently and determined accurately and provided in the bottom of the water pockets. Lateral drains shall be spaced as soon as the tap, all the pockets 16 feet centered as usual suffice. The main lateral should be placed in stable material. The minimum depth of the main 24 inches, lateral 12 inches below the bottom of the deepest pocket, unless the surface is a solid rock. The hard shell lies in lesser depth. In the case of the minimum depth of the main can be reduced in 12 inches below the bottom of the deepest pocket. The quite often softest huts of the clear matter overlie rock and shale. Unusual hard unlying and in hard unlying stratorium is not a uniform plane, but is irregular, and if the uniform will not conform the grade of the main, prevent the dislocation of the drain pipe is welded placed in the rock shell to depth of least equal to the diameter of the pipe. 421.2.2 grouting. 422.2.21 principle as described as water pockets are caused by the ballast being driven and subgraded due to the passing over the rails after the ballast has been driven out into the subgrade impervious soils. Heaving occurs of the long shoulder of the roadbed. Heaving material is an eerily sorely created action of the traffic vibration and the balance against the grade of the mixing earth of the water and forcing in the use of two of the ballast sections and the rule of the free water indicated below. The area is under the vibration. Grouting method of curing the condition of the consists of the pumping of the concrete slurry into the void and subgraded. The grouting is pumped into the place of voided filled and pressure has been raised in rod bed. The desired elevation is possible to determine the void of the water pocket. Effective water pockets under one of the ties. Effective water of a water pocket underneath the middle of the ties. Fill them with observing leakage in the grout up through the surface of the lung. The fill section of the grout consists of very fine sand, enough cement, and provided partially set of slurry. A rigid concrete of the base is desirable. Immediately following the grouting of the track, can check the elevation lined out of the face. 421.2.2.2 machinery equipment. If the grouting equipment is not available for the installation, equipment used for the pavement and mud jacking under ceiling is suitable for the road grouting. 421.2.2.3 other material uncertainly conditioned by bituminous materials may also be used in subsurfaces sealing. The method of for placing are similar to the use of cement and groutery slurry. 422 the slides. Generally, a slide usually unconsolidated material may occur in the face of the rock formation. Gravity is primary cause, supplemented by lubricating water, undermining natural and artificial clay type materials, certain type of geological structures, increasing the load in the case of the rock slide, specifically in the joint of the plate in fault planes and rock slides, specifically joint planes and fault planes and schistose structures. Strats are dripping toward the open face. In later cases of the slides, actually accentuated by the clay of the part in rocks and the embankments, the subject hydrostatic head of the length of time sufficient to saturate an embankment. Slides may be suddenly without warning, particularly when the material is disturbed, and by spreading as the operation corrective measures of each slide shall be considered by the individual problem that they cause, and they should be determined through the expert examinations of the determination of the engineer of the soil drainage conditions of the geological conditions related to the slide, the prevalence of the unstable material, and as uncertain in order to arrive at the decision economical performance between the time removal sliding material and the application of the suitable control method. Removal of the prevention of the cause of the slide important as in the restoration of the roadway piles of the retaining slide, retaining walls piles, and retaining walls of prevention of correction of the slides may be used in engineering evaluation. In 422.2.2 diversion of surface water must be intercepted diverted by the surfaces of dishes. 4.22.2.3 drains and underground is Water must be drained and intercepted ungraded and surfaces diverted and slide caused by the flowing of underlying material and often controlled by the construction subsurface drains contained in prefortiated draining around the toes of the slide when in the stable underlying material is deep. Tunneling and intercept of the following may be unnecessary: the feasible water cutoff and unusual, more economical, effective trenching and tunneling subsurfacing drains and perforated subtem is necessary to remove underground water from the side itself when impractical. Remove the sliding material on the hillside of the cutting slide, and the control method is usually coupled in removal of the sliding material. Also, slope modification, water cutoff, interception, drainage, tracing and tracing of the benching, sloping, slide lanes and load, and may lessen and prevent the sliding. They may be done additionally to using other methods of control. This removal entire moving mass hillside and cutting slides must be economical. Then control methods in 422.2.5 compact berms, and finally compacted the berms approximately 1/3 height of the fill will help stabilize the fill. May be used in connection with the drainage control methods. Wading in the toe of the slide and useless and movement exists throughout a mass. Whenever used in weight must rest upon be carried upon solid material. 423 frost heave. General water collects unevenly under the track expend ends because of the freezing. The track is lifted and the wet spots producing what was known as the heave track. In figure 431 432 extent of the heave cause of the action depends on the character conditions of the material and the ballast subgraded amount of the moisture maintained or retained and extended in duration of low temperatures. Corrective measures to maintain the shim trackage of the current costly maintenance time and repeated spiking off ties during the place of adjusting shims for braces and reducing the service life of the ties. However, such maintenance is necessary until the permanent corrective action can be taken. Carefully study the considerable work expenditure are warranted for the protection against the trackage having costed of the frost section. Drainage on the existing trackage, proper drainage and prior for actual eliminating the heavy heaving of the track. In isolated cases, the heavy heaving of the curves in isolated places of fills must be accomplished by digging out the soft areas of subgraded depth of 2 feet and more than causing excavation, shallow and an affordable proper drainage. So the crease a tendency to water pockets excavation. Should they be filled in which is clean coarse gravel or similar material, adequate depth of guide or good ballast applied under drains of wet cut installation, perforated under drains, backfilled and porous and materials provided excellent results. Subgraded and subgrade obstructs the drainage subballast section. It will be graded off to replace impermeable materials depth and necessary to correct the condition. The shoulders in some cases, whether the embankment is in the previous material grading in the shoulder, often the end of the ties is a deep 3 and 4 foot, replacing previous materials. Previous materials may be justified before undertaking the project. Carefully, exploration must be made. Be assured that the wet spots will be drained, and where the depression exists in the roadbed, free draining of the shoulder must be assured before the method of functioning. 423.2.6 stabilization of cement of the soil solely slurry. Figure 428 bituminous subsealing and may be used to this permanently stabilize road areas subject to freezing. Whether the heavy heaving is extensive and expenditure is justified, installation of membrane material may be considered in special areas. Traffic loads, frequency of the use of dependence of an installation railroad facility and must be considered, as well as availability, maintenance, crew manner, and equipment to do the work. 424 on drainage yard and track. The yards usually located in failure flat for terrain requiring special drain and treatment because the large opening ditches in the railroad yards and objective pipe storm of the subdrains are required unless natural soil particularly suitable for the self-draining. Periodically inspecting rotting, including of the installed draining system, and necessary if their function is satisfactory as conditions is the given installation. Additional facilities are added and clearly bounding in adjacent areas and increasing the watershed at the area, and it may be necessary to adjust the subsurface of the runoff facilities of the yard. 425. The vegetation control. Elimination of the vegetation from the area where it is not required. Erosion is essential to the economical maintenance of the track as well as as well as it is to appearance of the roadway vegetation. Vegetation should be controlled and eliminated least of limits of the ballast section to minimize the danger of the fears. The proper visibility of traffic signals must be maintained. Dirty ballast permits of the growth of the weeds and the interfere with drainage, shortens the life of the tires. Remedy is clean to the ballast is used to improve the herbicides and eliminate the vegetation from the ballast or the other areas. The road consulting specialist of the field of the best of the materials and method to use the weeds along the roadway may be controlled by mowing and burning or by using herbicide. Note it is mandatory that the personnel handling herbicide is certified. 4.26 snow and ice control. Snowfall amounts insufficient obstruction of railroad traffic. Hinder operation shall be expected in northern installations. Ice and snow packing and be problem crossing industrial areas, whether the track areas in the pavement. A snow plan shall be prepared in advance. Snow season in conjunction with the snow plan installation roads. The road must be contained in material. Main power procedure shall be to be used in varying storm conditions. Snow fencing snow from drifting on the roadbed. Localities with heavier snowstorms is frequently effective in placement of snow fencing is assured by keeping the records of location drifts that have occurred during the winter seasons. Snow and ice removal. Snow and ice will be removed promptly from the switches and frogs, guardrails, and flangeways and highway crossings. Also, snows and ice will be removed promptly. The loading platform, track seals, turnabout, transfer tables, and from any other of the places within personal property may be endangered. 426.4 chemical control. Snow and ice control chemicals. Sodium control. Sodium chloride, salt, and calcium chloride used. Urea effective melting ice package snow. Lowest temperatures within the chemical effective under field conditions usually in 26 degrees above 25 degrees Fahrenheit and minus 4 degrees Celsius. Calcium chloride 20 degrees Fahrenheit and 29 degrees below 0 Celsius. Snow battling heaters. Snow boiling cans may be advantages. Switches in series and snow conditions expected over the long period. Snow melting pots and switches. Heaters may be used. Electrical switch heaters is not recommended because of the high operating cost. But 427 the road cleaning up during the surfacing, aligning, engaging operation of the light. All deficiency noted by the corrected each of a working day. The shoulder must be clearly defined and burned, beams cleaned and raked and drained and ditches and cleaned and all scrape must be collected and taken in designated storage plan. Old ties units and further track of the cribbing and small be disposed of the burial land off another method of disposal that does not conflict with the pollution of laws. All rubbish and waste shall be cleared from the work and the entire roadway of the left in the scale of working man condition.